Hi everyone, so this is the video for lesson 1.5. So in this lesson we're learning a lot. We're learning our basic definitions for polygons and how to find the perimeter on the coordinate plane. Okay, so let's take a look at all these definitions we have. So a polygon is a closed plane figure formed by 3 or more segments. The closed part just means that all the sides connect. Okay, and we're going to draw some pictures of one in a second. So the sides of the polygons are line segments. The sides are always straight because they're line segments and they're never curved. The vertex of the angle or the polygon is where the two sides meet. A diagonal connects the non-adjacent vertices, so the ones that aren't next to each other. Diagonals connect those. Okay. And then we have a convex polygon where the diagonals are inside, and a concave polygon is where the diagonals are outside. And we're going to look at the difference between those in that chart in a second. So then a perimeter is the distance around a polygon, which ends up being the sum of all the sides. And area is the square units that fit inside. Okay, so in our chart, we're going to draw some examples of things that are polygons and things that are not polygons. So polygons are closed and they're formed by lines. Okay, so they can be anything that we can draw lines to connect. So things that are not polygons are anything that has curves on them, like a circle or the heart, or things that don't close. Okay, so you can draw any kind of shape you want here. Another good one would be like that. That's not a polygon because it overlaps like that, like it's like twisted. Okay, and concave versus convex. So convex, if you look at them, none of the things go in. Okay, and the diagonal thing, what that was talking about was a diagonal is a line that you can connect the angles, the vertices that are not next to each other. I didn't draw a very good line there. So, you know, in the shapes that have more sides, you can draw more. But in a concave one, the diagonals end up being, or you have at least one that can be connected outside. Or sometimes they'll like overlap if you try to connect them here too. Okay. So that makes it concave. That's the official definition. But what I'd like to look for is, you know, it has that word cave in it. So if it has this little area that forms a little cave, then it's concave. If it doesn't, it's convex. Okay. So our last thing on the front is to name all of our polygons. And I want you to pause the video and try to remember these names. I think you should know most of them. 7 usually people don't remember, and 9. Okay, so go ahead and try to fill in that chart that's down at the bottom with the names of polygons, and then I'll show you the answers. Okay, so here we go. There's all your names: triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, dodecagon. So if we don't know how many sides it is, or it's more than 12, we say it's an n-gon. So if it had 15 sides, it would say it's a 15-gon. They do have specific names, but they're crazy, like really crazy, and like 20 letters long and stuff. It's that hard to remember. For 4, you might have put like a square or a rectangle, but those are types of quadrilaterals, so the general name, if it has 4 sides, is a quadrilateral. Okay, awesome. So let's take a look at the back. So on the back, we have our area formulas at the top. Okay, so the height always has to be perpendicular to the base, and that's how when we look for the h, we have to look for the side that forms a right angle. Okay, so sometimes like in a triangle it could be outside like it is. In a triangle it could also be on the inside. But usually, well, I mean in here we could draw it on the outside too, so that would be the height. We represent the height with a dotted line because it's not part of the shape. Just how tall it is. Okay, and then there's your formulas that we hopefully know. They were on your summer homework too. Okay, so let's take a look at those examples and get those done. Okay, so for the first 4 we have to name them and tell if it's convex or concave. Okay, so This one, if we count the sides, we have 1, 2, 3, 4, 5, 6 sides. 6 sides is a hexagon. And there's no caves here. None of the diagonals, if we connected them from all of the sides, none of those lines would be outside the hexagon. Okay, so it's convex. Okay, so why don't you try the other 4 or 3 examples, and I'll show you the answers when we come back. One tip to help you when you're counting when it has a lot is to mark them as you go. So 1, 2, 3, 4, and so on. Okay? Okay, so pause your video, please. Okay, here we go. So we have this one's a dodecagon. There's 12 sides, and it's concave. We have another concave. It's an 11gon. And a pentagon is, and this pentagon convex. Okay? So remember, we can draw the diagonal from those vertices outside, and it makes that little cave there. Same thing here. Okay, that's why it's concave. Okay, awesome. Let's look at the bottom. So in the bottom, we have area on the coordinate plane. Okay? Well, this one's perimeter. Just kidding, perimeter. So we'll start by doing the perimeter. So we need to find the length of each side, okay, and then add them all up. So if we count vertical and horizontal lines, you can count. So 2, 4, 6, 2, 4, 5. Okay, so to find the length of AB, we're going to have to either use the distance formula, or remember that trick I showed you with the Pythagorean theorem? I would do the Pythagorean theorem there, especially since we know this. So this side is going to be C, A, and B, so 5 squared plus 6 squared equals that. So remember, we're trying to find the perimeter. That's the whole point of this problem, so that means we'll add up distance around. Okay, so we need this distance. And again, perimeter, or Pythagorean theorem, or the distance formula. So I'm going to do distance, or Pythagorean theorem. Sorry, my brain's thinking too fast and I can speak. Okay, so 25 squared plus 36 squared equals C squared. Or JK, I squared them. What is wrong with me today? So 25 plus 36 would be 61. And take the square root. So C equals the square root of 61. Okay, so if we're finding the perimeter, that means we will add up all the sides. So 5 plus 6 plus the square root of 61. So it's 11 plus the square root of 61. So that's the exact answer. It's 11 plus the square root of 61. But we can change it to a decimal and see. So we would do 11 plus the square root of 61, and we get 18.81. So this is approximately 18.81. And we don't know how big our units are, so we'll just write units. Okay, so a lot of times when you're doing perimeter, you're going to end up with some slanted sides. So you're going to have to use Pythagorean theorem or the distance formula to find that side. Okay? And then you just add up all the sides, and that's your perimeter. So for number 6, we're finding the area of that trapezoid named trap with those vertices. Okay, so for ones like this, we can use the area formula, and we'll just have to count how big the sides are. So if we look up at the top, it says that our area formula for a trapezoid is 1/2 times the height times B1 plus B2. Okay, so we'll count our bases. So we'll call this top side B1. It's 1, 2, 3, 4, 5. So B1 is 5. So that means the bottom is B2. And if we count the bottom, we get 12. One easy way to count it is, you can see it goes from 6 to 6. So 6 plus 6 is 12. Okay, so now we need to find the height. So remember, the height is always perpendicular to the bases. So since our bases are horizontal, that means our height's going to be vertical. So you can just draw it in wherever you want. So I'm going to say that this is my height right there, but I could have drawn it in anywhere. I drew it in. So that's 2, 4, 6. So our height is 6. So now that we have all of our numbers, we can plug them into our formula. So we have 1/2 times 6 times 5 plus 12. So half of 6 is 3 times 17. And 3 times 17 is 51 units. And since it's area, it's always squared, because remember that's how many square boxes can fit inside our shape. Okay, so that's it for that kind. So let's take a look at number 7, because number 7 is kind of completely different. So we know that this is a triangle, so we do have a triangle formula for area, but can we see the height here? Or the base? Remember, our height and our base have to be perpendicular, so we don't have any lines that are horizontal or vertical, which means we can't see our height or our base. So there's a special trick to find the area of this kind of shape when it's not like nice like this with horizontal and vertical lines. And the first step is to draw a box around your shape. Okay, so we want to make a box that touches each of the vertices. Well, sometimes each of the vertices. Sometimes you have to skip one. Okay, but we don't want to make it bigger than our shape that we have. So I'm gonna just kind of shade this in so we can see. So what we're trying to do is find the area of that shaded region. Okay, so can I find the area of the box that I just drew around my triangle dog? I could. And can I find the area of each of these triangles? I can find those too because they have horizontal and vertical sides. So that means that's their height and their base. So now think about it. If I have the area of the whole box and the area of those pieces that we don't want, can I use that to get the area of what we do want? Very good. I hope you thought, yes, we could subtract them, because that's exactly what we're going to do. Okay, so we have a couple different things to find, but then we just subtract them from the area of the whole box. Okay, so I'm going to label these triangles to keep them straight. Okay, so the area of our box, so it's just a parallelogram, so base times height. So 2, 4, 6 times 2, 4, 5. So the area of the whole box is 30. And we'll do the area of triangle 1. So 1/2 times 2 times 2, 4. So 1/2 of 2 is 1. 1 times 4 is 4. Then we repeat. So the area of triangle 2. 2 times 2, 4, 5. So 1/2 of 2 is 1, times 5 is 5. And now the area of triangle 3. So that's 1, 2, 3. 1, 2, 3, 4, 5, 6. So for this one, I would 1/2 of 3 is a decimal, so 3 times 6 is 18, so 1/2 of 18 is 9. Okay, so triangle 1 plus triangle 2 plus triangle 3, if we add all those together, we get 9 plus 9 is 18. Okay, so the area of the pieces that we don't want is 18. The area of that whole thing is 30. So the area of triangle dog, the triangle, equals 30 minus 18, so 12 units squared. Okay, so with this method, we enclose our figure, find the area of the whole box we use to enclose it, find the area of the pieces, and subtract from the box. And that's it. So I kind of like these, they're kind of fun. Okay, so I'm going to get you started with this one, but then I'm going to have you try it on your own, okay? So again, first we'll draw our box around our shape. It helps if you use a ruler, because then like you won't count wrong. Remember, you're counting to the vertices, so like here they get really tight together since it's only one tall. So that's why it helps with the straight lines, you know, with a ruler. But as long as you count to the vertices, you should be okay. Okay, so there's our main box, But if you look, this part right here is not a triangle. So that means we need to connect to that other vertice too. So if I split it like this, now I have 2 triangles. Okay, so just be careful when you're finding your height. It's actually that piece inside. And then those are the 2 bases for each triangle. Okay, so I'm going to label them. 1, 2, 3, 4. So we'll do area of the box, area of triangle 1, triangle 2, triangle 3, and triangle 4. And then add them up, add the triangles, and subtract from the box. Okay, so go ahead and pause and try that one on your own. Okay, so for our box we had 56 or 7 times 8. Triangle 1, here, let me just show you my calculations. Okay, triangle 1 was 6, triangle 2 was 6, triangle 3 is 7, triangle 4, that weird skinny one, is 4. So all of our triangles added up to be 23. And that means our whole weird height thing here is 33 units squared. Okay, so just like with every video, make sure you write down your questions and ask them in class tomorrow. Werner out.